Magnetic effect of electric current. We have learned about heating effect of electric current. In previous standards, we have studied about magnets and magnetic lines of force. However, it will be interesting to see if an electric current and magnetic field are related to each other. Try this. Connect the circuit as shown in figure. Connect a copper wire, thicker and straight as compared to the connecting wires between A and B. Keep a magnetic needle adjacent to the wire. Keep the plug key open in the circuit and observe the direction of the needle. Close the plug key and observe the direction of the needle. What do you notice? Now, interchange the connecting wires connected to the cell and observe the direction of the magnetic needle. Do you notice any relation between the direction of current and position of the needle? What do you learn from this experiment? The magnetic effect is observed because of the current in the wire. This means electricity and magnetism are closely related. On the contrary, if a magnet is moved and kept moving, will we observe any electric effect? Is it not exciting? Therefore, we are going to study magnetic fields and such electromagnetic effects. Finally, we will study the principles, construction, and working of electric motor and electric generator. Introduction of scientist. As a scientist at the forefront in the 19th century, Hans Christian Ørsted played an important role in understanding electromagnetism. He observed in 1820 that when a current passes through a metal wire, the magnetic needle near the wire turns through a certain angle. He pointed out the relation between electricity and magnetism. Today's advanced technology is developed as a consequence. In his honor, the unit of intensity of the magnetic field is termed as Ørsted. Try this. Connect the circuit as shown in figure. When a large current, approximately 1 A or more, flows through the thick copper wire passing through a cardboard, the magnetic needle kept at different points on the cardboard around the wire stands in different directions. Mark these directions with a pencil. Discuss with your friends and teachers about the requirement of the current, number of cells, cells of what potential difference, thickness of the wire, etc., and then perform the experiment. The direction of the current shown in the circuit is its conventional direction. What changes are caused by increasing or decreasing current? What do you see when the magnetic needle is kept a little away from the wire? Now, instead of the magnetic needle, spread iron filings on the cardboard and observe. The iron filings arrange themselves in a circular manner around the wire. Why does this happen? You have studied magnetism and magnetic field in previous standard. The iron filings spread along the magnetic lines of force. Always remember, a magnetic field is produced around a straight current carrying conductor. If the current is unchanged, this magnetic field reduces as the distance from the wire increases. Therefore, the concentric circles representing the magnetic lines of force are shown bigger and rarefied as the distance from the wire increases. If the current through the wire is increased, the intensity of the magnetic field increases.